Sodium bicarbonate, also called as baking soda, is a crystalline salt found in natural mineral form in knuckle-like deposits. The science of baking soda, this unassuming salt, has a multitude of domestic and industrial uses, including as a food additive, medicine, and cleaning product. One of the baking soda's most common use is for cooking, often as leavening agent in baked goods. It also helps people with acid reflux to settle the stomach by acting as an antacid. To write the formula for baking soda, it's helpful to know that baking soda is called sodium bicarbonate. That's a bit of an older name though. The modern name that we use is sodium hydrogen carbonate. And if you know, this is pretty easy to name. So for sodium, we know that the symbol is Na, hydrogen is H, and then carbonate, you need to look that up. On a common ion table, it's CO3. It's a polyatomic ion, so the carbonate is CO3. We know that sodium has a +1 charge. It's in the group 1 of the periodic table. And hydrogen, it is also in group 1. It has a +1 charge. The carbonate polyatomic ion is always in a -2. So as you can see, +1, +1, and a -2, that adds up to 0, so the net charge is 0. And that's how we come up with NaHCO3. Sodium bicarbonate molecules feature one sodium cation and a bicarbonate anion. Here an ionic bond is formed between the positively charged sodium ion and the negatively charged oxygen, which is signally bonded to a central carbon and not bonded to a hydrogen atom. Now that we've gained a basic understanding about baking soda, let us move on by solving this problem. A 50.75 grams of washing soda, a heated sodium carbonate, is found to contain a 30.69% of sodium, 4.22% of hydrogen, 20.012% of carbon, and 15.96% of oxygen. Find its molecular formula when the compound has a 63.78 grams per mole. What we are looking for is the molecular formula, but we need to find first the empirical formula since it was not given in the problem. In solving the empirical formula, we need to determine the first na given. What we have here are sodium, carbon, hydrogen, and oxygen. Sodium has a percentage of 30.69, while hydrogen has a percentage of 4.22, carbon has a percentage of 20.012, and oxygen has a percentage of 15.96. Moving on, we need to multiply each element to 100 grams so that we can convert the percentage to grams. Therefore, sodium will have a 30.69 grams, hydrogen will then have a 4.22 grams, while carbon will have a 20.012 grams, and oxygen will have a 15.96 grams. Next step would be to convert the grams of every element to moles. 30.69 grams of sodium should be multiplied to 1 mole over its atomic weight, 22.990 grams. Cancel the grams will give us 1.33 moles. 4.22 grams of hydrogen should be multiplied to 1 mole over its atomic weight, 1.0078 grams. Cancel the grams will give us 4.19 moles. 20.012 grams of carbon should be multiplied to 1 mole over its atomic weight, 12.012 grams. Cancel the grams will give us 1.67 mole. And 15.96 grams of oxygen should be multiplied to 1 mole over its atomic weight, 15.999 grams. Cancel the grams will give us 0.99 moles. Next step to do is to divide the elements on the smallest value, so sodium is 1.33 all over 0.99. Hydrogen would be 4.19 all over 0.99. And carbon will be 1.67 all over 0.99. And oxygen will be 0.99 all over 0.99. Calculate each one of them. So for sodium, we will have 1.34 or approximately equal to 1. Hydrogen will have 4.23 or approximately equal to 4. carbon will have 1.59 or approximately equal to 2, and oxygen will automatically be equal to 1. Now that we already had the subscripts for the element, we will now have its empirical formula, which is NaH4C2O. After getting the empirical formula, we will now move in getting the molecular formula. First, let's identify the given. We had our empirical formula NaH4C2O and our molar mass 63.78 grams per mole.
The first step is to calculate the empirical formula mass. From our empirical formula, mass of sodium is equal to 1 mole times its atomic mass, which is 22.990 grams or approximately 23, will give us 23. Mass of hydrogen is equal to 4 moles, since we have 4 moles of hydrogen times its atomic mass, which is 1.0078 grams or approximately 1, is equal to 4. Mass of carbon is equal to 2 moles, since we have 2 moles of carbon times its atomic mass, which is 12.012 grams or approximately 12, is equal to 24.
And the mass of oxygen is equal to 1 mole times its atomic mass, which is 15.999 grams or approximately equal to 16 grams, is equal to 16. Add all the mass of the elements and that will give us 67 grams per mole. Next is to divide the molar mass to the empirical formula mass. 63.78 grams per mole divided by 67 grams per mole is equal to 0.95 or approximately equal to 1. Multiply the empirical formula to the value that we got a while ago. Then we will now have our molecular formula, which is NaH4C2O.
Hi everyone! It's my birthday! OMG, it pops! I have an idea! Let's make another one! Prepare a funnel, stirring rod, baking soda, acetic acid or vinegar, graduated cylinder, and our balloon. First, we need to put the baking soda inside the balloon using the funnel.
Is we need to put the acetic acid in the graduated cylinder.
And then attach the mouth of the balloon on the mouth of the graduated cylinder.
When baking soda and acetic acid mix together, it creates a gas called carbon dioxide. The gas begins to expand in the bottle and starts to inflate the balloon. Initial reaction results carbonic acid and sodium acetate. Then in the composition reaction occurs, reducing sodium acetate to water and releases carbon dioxide.
Finally, I made it!